This is section 2.5, Implicit Differentiation, day 1. So remember, we talked about different ways to write a derivative. So we could do y prime or f prime of x, or we could do dy dx. Okay, they all mean the same thing. Today we're going to focus on using this dy dx form. It works to use the y prime form, but I prefer the dy dx. So explicit or implicit form, we've been dealing mainly with explicit form. So it's a function written explicitly as a function of x. So it's going to be a y equals something. So like we have y equals 1 over x. Implicit form is a function written as a function of y and x. So it's not solved for y, or we might have y's all over the place, or x's all over the place. So xy equals 1. Notice that these two are the same equation. They just look different. Explicit versus implicit. So when we do implicit differentiation, we're taking the derivative of a function in implicit form. Like I said, we're going to use dy dx. You're going to take the derivatives of x like normal, but use the chain rule when you take the derivative of y. So to find the derivative with respect to x, so d dx of y cubed, we do our power rule like normal. We bring down the 3 and then raise it to a 1 less. But then, since it's not an x, we're going to multiply by dy dx. So that's saying times the derivative of y with respect to x. So let's find each derivative with respect to x. So this first one, d dx of x plus 3y. Well, the derivative of x is pretty easy. Remember, that's just 1. And the next one, so plus the derivative of 3y. So think of the derivative like normal, which would just give us 3. But since it's a y, we have to put dy dx. So their derivative is 1 plus 3 dy dx. And our next one, derivative of xy squared. This is actually a product rule because it's like we have two different pieces. So we do our product rule. So we take the first times the derivative of the second. So the derivative of y squared is 2y, and since it's y, we have to do dy dx. So that's 1d2 plus 2, which is y squared. The derivative of x is 1, so I'm not going to write times 1. So we could simplify this, I guess, if you wanted to be 2xy dy dx plus y squared. So for implicit differentiation, now we're going to say, okay, let's do derivatives, but now let's throw in an equal sign. We're going to differentiate both sides of the equation with respect to x. We're going to get all the dy dx on one side and move everything else to the other side. We're going to end up having to factor dy dx and solve. So our goal is to get that dy dx by itself after we do the derivative. So let's find each derivative using implicit differentiation. Looking at that first one, y cubed plus y squared minus 5y minus x squared equals negative 4. So let's go through and do the derivative first. So the derivative of y cubed is 3y squared dy dx. The derivative of y squared is 2y dy dx. The derivative of negative 5y is minus 5 dy dx. The derivative of negative x squared is negative 2x. And the derivative of negative 4 is 0. So I have 3 terms that have a dy dx. So I want to get rid of everything that doesn't have a dy dx. So I'm going to add 2x to both sides. So now we have 3y squared dy dx plus 2y dy dx minus 5 dy dx equals 2x. Now, since all of these terms on the left side have a dy dx, I'm going to factor that out. So we have dy dx times 3x squared plus 2y minus 5 equals 2x. And to get dy dx by itself, we're going to divide by what's in that parentheses. So dy dx in this case is equal to 2x over 3y squared plus 2y minus 5. Notice that your derivative is going to have both x's and y's in it most likely, and that's okay. All right, let's do the next one. So looking here, let's find the derivative. So this first part, x cubed y, is a product rule. So we have 1 d2, which is dy dx, plus 2 d1, so the derivative of x cubed is 3x squared. And then derivative of negative 2x squared is minus 4x. Derivative of y to the fourth is plus 4y cubed dy dx. Derivative of 8 is 0. So what I want to do is I want to go through and I want to find all of my dy dx terms. And they're all on one side, so let's get rid of everything else. So I'm going to subtract 3x squared y, and I'm going to add 4x to both sides. So now we have x cubed dy dx plus 4y cubed dy dx equals 4x minus 3x squared y. All my dy dx's are by themselves, so I'm going to factor out a dy dx. X cubed plus 4y cubed equals 4x minus 3x squared y. And then divide, so dy dx equals 4x minus 3x squared y all over x cubed plus 4y cubed. And I'm going to skip to this last example, just so we have an example of trig here. All right, so cosine of x squared, the derivative, so cosine goes to negative sine. So negative sine of x squared. Chain rule, multiply by the derivative of the inside, so I'm going to put a 2x there. Plus sine goes to cosine. So we have cosine of y cubed times the derivative of the inside, which is 3y squared dy dx, equals 0. The derivative of 6 is 0. Go find all my dy dx terms. Get rid of everything else. So we have 3y squared dy dx cosine of y cubed equals 2x sine of x squared. I want the dy dx by itself, so I'm going to divide by everything else. So we have 2x sine of x squared over 3y squared cosine of y cubed. If you were able to simplify at this point, you would go ahead and simplify. But that is implicit differentiation.